So when we are solving today, what we're going to have to do is we are going to need to solve, I've just picked up problems today where we are going to have to solve the first equation for either x or for y. This is just a sample problem up here. So above and beyond the ones we will practice together. But they picked the first equation to solve for y. Can anybody tell me why that would be the most efficient way to go about that? Jacob?
If you do that as the thing that you're going to solve for, if you're going to solve for y, then you would only have to do one step.
You only have one step to do. Add x to both sides. What if you decided to solve that equation instead for x? How many steps would it take?
2.
Then it would take 2 steps because you'd move the y over first, and then you'd have a negative x, and a negative x is not a solve for x. It's still getting multiplied by -1, so now we'd have to divide everything by -1, so we just made it into a 2-step problem. Doesn't mean we can't do that, but it's probably not the most efficient way. Same thing with, if we take the second equation, oh, look at that one. What if you had taken 2x plus 3y equals 27 and decided to solve that one for, I don't know, let's say we decided to solve it for x. What would happen? We'd get a fraction, wouldn't we? Because we'd be moving the 3y over, and then we'd have to divide every piece by 2. And is every coefficient or every constant up there an even number? No. So then we just really would make it more work for ourselves than we would need to. So again, we have to kind of, at this point, this is the thing today, we have to make sure that we make a good choice of which one, oh, why isn't that working? What choice we're going to make to get a y or an x alone. Doesn't matter. We can do whichever one we want, but we want to learn how to make good choices. Okay, so let's look at our first one we're going to do together. X minus y equals -3. 2x plus y equals 12. Anybody want to suggest one we should start with? Jacob?
2x plus y equals 12.
You want to take the 2x plus y equals 12 and do what?
Solve for y.
You want to solve it for y. Okay? Anybody like that idea? Huh.
It's okay either way.
It's okay either way? Doesn't really matter. What would be another? That's like, it looks like it would only be a 1-step process, right? Okay, how about, is there another one we could do? It would only be a 1-step process? First one we could solve it for x, and it would only be a 1-step process, right? Okay. So we have a couple of good choices here. So just to stay consistent with how I have the completed notes online, we're going to solve the first one for x. And I want you to put this in your notes if that's what we're doing. Solve x minus y equals -3 for x. It wasn't our only choice, but it's the one we're going to make. So that would mean we need to write down our equation and do the process of getting x alone. So we're going to do what?
Add 3.
Add 3?
So add y.
Add y. We want x alone. Y is being subtracted from x. So let's add it so it'll go over to the other side, and we'll have x equals -3 plus y. Okay. Now, we're basically saying we just renamed that first equation. That's really all we've done is we have renamed this now. So we're just going to take the time to write down its new name here. We're going to say this is going to become x equals -3 plus y. And the other one, we're just not going to mess with it. No need to. We only need one of them solved for x or for y. Because now we're actually ready to do what we did yesterday. We circled the expression that the single variable was equal to and said that has to go into the other equation for that variable. So we're ready to do our substitution step. So 2, parenthesis, -3 plus y equals 12. Okay, go ahead and solve for y. Anybody agree with me? Y equals 6. And if you don't, maybe we better figure out why, or if I need to be challenged, or... Okay? Because if we are, then we're going to go on and we're going to now solve for what?
X.
Solve for x. Now, we're not really doing a check problem here. Like, you know, when I say to you, whenever you're doing a check problem, always go back to the original equations and work with them there. If you want, you can go back to our first equation renamed, because there we already have x alone. So we could say, you know what? That looks like a pretty handy one to use. We actually have 3 choices to go back into to solve for y. We could use the first equation in its original form. We could use the first equation in its renamed form. Or we could use the second equation if we so want. Either way, we should get the same x value. And what is our x value? 3. So, what's our solution?
36.
Ordered pair, 3, 6. So, the first column, before I drew the vertical black line that going down there, first column is the new stuff, everything else is what we did for today. And wrong for today. So, any questions on this? Okay, let's go to the back side. I always do, they look so nice and neat, and oh my goodness, I got a 1y or a 1x, and then we have to make a decision. And again, does it matter which equation we solve for x or for y? Does it matter whether we solve for x or we solve for y? No, it doesn't matter. We get to choose. So we have options here. We could solve the first equation for x. We could solve the first equation for y. We could solve the second equation for x. We could solve the second equation for y. Okay, I'll take your suggestions. Anybody want to offer up a suggestion? Which one we should do? Abby?
First one for x.
First one for x. Okay, so let's solve 2x minus 4y equals 20 for x. It's good for us to have in our notes. What were we doing? Other than just, you know, like I tried to tell you guys to do your SQ3Rs, say something to yourself. Explain to yourself, what was I doing here? Okay, so we have 2x minus 4y equals 20. We want x alone. First move, add 4y. Okay, next move. Divide everything by 2. So 2x gets divided by 2, 20 gets divided by 2, 4y gets divided by 2. And we have our new name for the first equation is x equals 10 plus 2y. So remember what we're going to do? We're going to go up here, in our notes at least, we're going to go up here and we're going to say, okay, here's the new name for this one.
x equals 10 plus 2y. Same line, same equation, just a different name. 10 can be renamed as 20 over 2. But they're the same thing, really. And then the other one we're leaving as it is. 4x minus 16y equals 32. Now, to be honest with you, I might have chosen the second equation and solved it for x, because then I wouldn't have had these big numbers to work with to substitute into. Okay? So I might have taken the second equation, because then I would have gotten to divide everything by 4, and I'd have maybe had some smaller numbers to work with at least, but it doesn't matter. So now let's go and we're going to say, we're going to take this right here, put it into this equation for x. So 4 times 10 plus 2y minus 16y equals 32. Okay, go ahead and solve for y. Do you agree? Disagree? There you go.
Why is it negative 1? Because they're both being divided by.
That's a good question. I think it should be what?
1.
Positive 1, yeah, good job. So I asked you if you agree with me. Okay, so now that we have y, what's left?
X.
Find x. Find x. And we're going to go with our new named equation, which is x equals 10 plus 2y. So x equals 10 plus 2 times positive 1. And x equals 10 plus 2. X equals 12. So our solution is order pair 12, 1. So probably in reality, hopefully, this part that's showing on the smartboard right now, that part we conquered yesterday. Hopefully, you will understand how important this step is, the very first one here. If we don't do this step, well, it sets us up for not being successful with the rest of it. So you have to make sure you do a good job in that first step today. Okay? You help set yourself up for success. So any questions? Okay, what do I have, an application problem for us to do? Of course. And we will use a system of equations to solve this. So, read through the problem first of all, and then I want you to, I always want this. X is, Y is. What are they representing in your system of equations? What are those variables, X and Y, representing, first of all, before you even set the equations up? So what should we letter write? Oh, look at what's the thing they want you to find. I underlined it.
X is the cost of a UCD?
Okay, X is the cost of a used CD what would Y be? Total cost altogether? Do we have enough information to, is it saying when will they have, you know, spent the same amount? Do we need to know that? Not the total.
Why can be the cost of the used DVD?
Yeah, it's the cost of the used DVD. Those are the two things we don't know. Those are the two things we don't know. This is gonna be more like when we have to find two numbers. Then they're kind of, you know, like, really looking for the same thing, a number and a number. Here we're looking for a cost and a cost, okay? So, any suggestions of what kind of an equation we could set up? Considering the information they gave us. Kate bought 3 used CDs and 1 used DVD at a bookstore. A friend Joel bought 2 used CDs at the same store. Kate spent $20 and Joel spent 22. How do you think that?
20 equals 3x plus 1y.
Okay, so 20, how much money Kate spent is equal to 3x. She bought 3 used CDs plus 1 used DVD. Okay? So that's Kate. Basically, we just set up an equation that represents Kate. How can we set, what would our equation look like for Joel then? Since he's the other one involved in this. New man, Courtney.
22 equals 2x plus 2y.
Joel spent $22, bought 2 CDs and 2 DVDs. There's our system of equations. Okay. What do you want to do? You're going to solve for X and Y. Abby?
Solve the first one for y.
Okay, let's solve the first equation for Y. So solve 20 equals 3x plus 1y for y. By the way, would it hurt to take this 1 out of here? Maybe we would like how it looks better. Does it hurt? Take that 1 out of there. Okay, so we're going to solve that first equation for y. And so 20 equals 3x plus y. What do we have to do? Subtract what? 3x. Okay, subtract 3x from both sides. We now have 20 take away 3x equals y. So now we're going to say, okay, I just renamed this equation. It became 20 equals, or no, not 20, equals 20 minus 3x equals y. And the other one, we're leaving just like it is. Because now we're going to take this expression and put it into this equation for y. Okay. So let's substitute in. We'll have a 22 equals 2x plus 2 times 20 minus 3x. How about we make this add the opposite? It's subtraction with distributive property. Might help us be more successful. Okay, go ahead and solve this for x. that okay? Because what's X representing again? Cost of UCD, so we just found out that it is $4.50. Okay, so now that we know that, now we can move on and solve for what? Now we need to solve for y. Okay, so we're going to go solve for y next. Okay, just slow down here. Solve for y. Well, I'm thinking I'm going to want to use the one that we did solve for y already, which is y equals 20 minus 3x. So y equals 20 plus a negative 3 times 4.5. Six and a half, 6.5. You know, in other words, we just found out what? Yeah, the price of a used DVD, and it is $6.50. Okay, so this is an application problem. We answer in a sentence. What's our sentence going to be? Or we asked, determine the cost of a used CD and a used DVD.
The cost of a used CD is $4.50. The cost of a used DVD is $6.50.
Yeah, the cost of a used CD is $4.50, not 4.5. It's money. And the cost of a used DVD is $6.50. So again, you have the application problems in your homework, and if you solve them without the system of equations, I'm not going to consider that because that's what we're practicing in this particular lesson. That there can, these problems can be solved sometimes with systems of equations, and I know all the ones you're going to do in your homework can be.